to all our viewers out there. My name is Heinrich Neetling, and this is Mathematical Literacy. In today's lesson, we'll be looking at the topic of probability, but more specifically, probability in context. Now, before I start with the lesson, let me quickly check with you. Did you know that probability plays a vital role in the day-to-day life? In the weather forecast, sports and gaming strategies, buying and selling insurance, online shopping, you name it, probability plays a role. Studying probability helps children to develop critical thinking skills and to interpret the probability that surrounds us daily. Now let's see what I will expect of you in today's lesson. So by the end of this lesson, you should be able to distinguish between theoretical and experimental probability and perform calculations related to it. You should also be able to express probability using fractions, percentages, as well as decimal notation. Then, you must be able to interpret two-way tables and tree diagrams. You must also be able to draw and complete two-way tables and tree diagrams. And then, you must be able to perform calculations based on two-way tables and tree diagrams. Now, let's look at the pre-knowledge, meaning what you should know at this moment in time. So I indicated here that probability is the chance or likelihood of an event occurring. Okay, so what is the chance or likelihood of something happening? Then I also indicated that we can express probability as a percentage, a common fraction, or a decimal fraction. Then the formula that we use when calculating probability is where we take the total number of favorable outcomes and we divide that by the total number of possible outcomes. Now, this is more or less the idea of what we will be focusing on in today's lesson. So we'll look at theoretical versus experimental probability. Thereafter, we will look at two-way tables. And then lastly, we'll look at tree diagrams. Now, let's quickly do a quick short practice, right? So question 1. I said here that a pharmacy advert stated that they have created a new HIV/AIDS test that you can take home. It claims to have 80% accuracy. Now the question at hand, is the above an example of experimental or theoretical probability? So looking at this statement here, we can see that this is an example of experimental probability. Hence, we can say that this pharmacy should have tested this product. Now they say it has, or they claim for that matter, that there's an 80% accuracy. Okay, so we agree it's experimental probability. Question number 2. It says here, define the term tree diagram. Okay, so a tree diagram is a diagram, a way of us being able to represent possible outcomes visually. Okay, so it's a diagram in which we can actually present outcomes visually. Okay, so that is more a tree diagram. And then our last question here, true or false? Compound events can be represented by tree diagrams and two-way tables. Yes, indeed, that is true. Okay, so we use two-way tables and tree diagrams to basically represent compound events. Okay, let's look at what else will be important to you. So now we're going to look at important words related to probability. So first up, I indicated here that theoretical probability is the purely mathematical calculation of determining the probability of an event occurring out of the total number of possible events, right? Then, opposite of that is your experimental probability. So here we look at the number of times the event occurred relative to the number of trials of the event. Okay, I know at this moment in time it's a mouthful, but we'll put all of this into practice. Then, a prediction. So what is a prediction? It is a statement about a future event or outcome based on the probability of historical data or statistics of a past event or outcome that took place over a long period of time. Then I also indicated here that frequency is the number of times an outcome has occurred. You'll see how important this is, especially when we're going to deal with theoretical and experimental probability. Also important is that a compound event is a situation which involves the probability of more than one event, right? So important to note, it's more than one event, where each event takes place independently of the other. Also important is that a two-way table, it's known as contingency table as well, is a table which shows all the possible outcomes of the event down a column, the possible outcomes of another event across a row, and the resulting compound event or outcomes displayed in the middle of the table. Again, we'll look at that once we're going to do a sum based on that definition. And then I indicated here that a tree diagram provides us with a way to visually represent all the possible outcomes of compound events. It's shaped like a tree with the branches representing all the different possible outcomes. Okay, so there's the revising words and language that you should be familiar with. Let us quickly take a short break. After the break, we'll put all of this into practice. See you now.